welcome my awesome friend. I hope you all are great. Today's lecture we are going to talk about one of the most important topic in the ETAP, which is store protection and coordination. So go get your coffee and let's start. First of all, we will need to enter a new project. Let's call it store protection. And OK, and OK. Let's maximize the one line view. First of all, let's draw a simple single line diagram. It's going to consist of, let's first use 60 Hertz instead of 50 Hertz. Okay, let's first draw the power grid, which is going to supply the power. Second, let's draw one busbar right here and another right here and third right here and the fourth one right here. Okay, now let's see, we have a two winding transformer connecting between the busbar 1 and busbar 2 like this. Also, we will have a cable is going to connect between this point and this point. Okay, let's remove this busbar, we don't need it. Let's increase the length of this busbar and this busbar. First thing, we will have a 4 loads. Let's say 4 lump load, one right here and another one right here and the third one right here, and the last one is going to be on this busbar. Let's enter the data for each element. First, the power grid will have the rating of 115 kilovolt and the short circuit is going to be 1400 megavolt ampere short circuit, and the X over R is going to be 20, and there is no harmonics, so we are going to remove any harmonics. Second thing, let's edit the rating for the transformer. The transformer secondary voltage is going to be 34.5 and the megavolt ampere for it is going to be 58.45 megavolt ampere. Let's say the rating factor for now is 0. Let's enter the impedance, it's going to be Z over and X over R, typical and typical value for the no load test, and press OK. First, let's enter the data for the load. We have a 3 or the 4 typical load is 10 megavolt ampere with a power factor 85%. All the impedance is constant Z, so there is no back EMF, no dynamic load. All the data is a static load, let's say static load, and 10 megavolt ampere, and press OK. The third one also 10 mega and constant Z, 100% constant Z, and also 10 mega and constant Z, and press OK. Now we have entered all the data except the cable. Let's enter the data for the cable. We are using 1 kilometer. Okay, the distance 1 kilometer cable. The cable we are going to use 2 conductor per phase. Okay, library we are going to use the voltage we are at is 35, so we are going to choose 35 kilovolt. there is many type of the 35. We are going to choose this one. It's in my right, so we are going to choose this one, ABR and magnet. Okay, and it's going to be the cross section area is 350, and press OK and press OK. Now we have entered all the data. Let's go to load flow analysis to make everything going well. Load flow analysis. You can see right here there is only two marginal error because we are operating at 95.3 and 90.95.1 for the busbar 2 and busbar 3. Of course, that's done because of the transformer impedance. We said we can overcome this by adding the tab. Let's say we are going to change the tab in primary, of course not the secondary, because the primary has the lowest current because it has the highest voltage. So let's reduce it by -2%, and let's run the load flow analysis again. Let's see, still 97. Let's reduce it, go again, go the tab, and instead of -2, let's say -2.5, and press OK. And this time and run the load flow. It's still 97. Let's see, we can change it by -3. There is no any marginal error now. Everything going fine. Okay, first of all, let's save this file. Okay, everything is going fine right now. Everything, the voltage drop, there is no voltage drop. Let's add our overcurrent relay and the current transformer. Let's say we have a current transformer for each load. Okay, one right here and one right here and the other one right here. Okay, no, okay, and one to protect the cable, and one to protect this bus bar, and one to protect the transformer. Okay, now as you can see we have typically 1, 2, 3 and 4 and 5 and 6 CT and 6, of course, 6 multifunction relay or OCR. Let's say this one and 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 this one. Okay, let's go after adding all the OCR. Let's run the load flow analysis again to enter all the data for the OCR. First of all, by double click on the OCR, you can see two tabs. The library tab, we are going to choose for now the specific one, the CO4 from ABB, this one, and let's say CO4. We are going to use two things in overcurrent relay, the pickup setting and the instantaneous setting. As you can see in the setting of the overcurrent relay, there is two tab right here and another tab over here. This tab is used for the overcurrent and this tab for instantaneous. The overcurrent tab is used for the inverse time tripping, and the instantaneous tab is for the instantaneous tripping. Of course, the overcurrent tab or the inverse tripping is very important, because when you are increasing the value of current, we will need the time of tripping is much shorter, so it's called the inverse tripping. Let's say okay for now, and let's go to this tab first, and let's enter the ratio of the CT. The turns ratio of the first CT, let's say the primary is 605, 600 over 5, the CT, and the CT is going to have also 600 over 5, and the CT, because it has a higher current, let's say is going to be 700 over 5. Okay, but this CT, because it has a higher voltage, it will have a lower current, so we are going to go to 500 over 5 and press over 5, of course, and press OK. Of course, this load is similar to this load and similar to this load, so whatever is going to happen for this relay is going to be designed for this relay. So let's enter the rating for this one as 600 over 5 again, and enter, and the CT as rating 600 over 5, and OK. Let's start with the first relay. Let's design this relay first. As we said, the OCR or the overcurrent relay we are using is CO5 from the company of ABB. There is two part of setting, this setting or overcurrent setting and instantaneous setting. The overcurrent setting is used to trip when this relay is overloaded. So we are going to need the current from the load flow. The higher current from load flow, this mean is going to go overloading, and the current from the instantaneous setting should be lower than the fault current. So let's start with the load flow analysis and get the value of the current flowing to this load. Let's choose from right here the kilovolt, ampere and ampere. Let's choose the ampere only, we will need the ampere and the value of it. Okay, as you can see, we will need about the current 164.1 ampere. Double click on it, let's go to OCR. This means we will need nearly current. This is the instantaneous current. Let's go to the pickup or the overloading. This is the overloading. We will need higher than 60. If we went to 2.5, as you can see, is going to be 300. 300 is very high. Let's go to 1.5. 1.5, this means over higher than 164. This relay is going to trip as inverse when I reach 1.5 or the 180 ampere. Let's see, one pickup will get the 120. 120 is less than 164. This means when the lumped load is operating at normal case and drawing the current of 164, this relay is going to trip inversely. So the one pickup current is not correct for this relay, so we are going to choose 1.5. And of course you don't need to use the 2 because the 2 is very high, so we are going to choose only 1.5. Okay, as you can see also the time dial right here, we will explain more later, but let's leave it for now 0.5 and press OK. Whatever I did for this relay, let's do it for this relay. OCR, the type of this relay is ABB, it's CO4, and press OK, and we are going to use the 1.5 and press OK. And also for this relay OCR, the library ABB and CO4 and press OK. We are going to use 1.5 pickup current, 1.5 ampere and 0.5 dial. As you can see, now we have added the pickup current. Let's add the pickup current for this relay also. Let's see, amount of current is going to flow through this relay. The amount of current is going to flow through this relay is about 492.2. So we are going to choose the OCR, the same manufacturer, CO4. Okay, and let's see the highest one, 2.5. 2.5, as you can see, the primary is going to be 300. 300 is less than the normal case of the 492.2, so we are going to choose the higher one. Let's see this one, and go to 3. 3 is also 360. Let's go to 3.5, also less. Let's go for 480. Let's go to 5. 5 is the most acceptable case, as you can see right here. It's going to give us 600. 600 is acceptable. It will operate at when this case is overloaded. When we went to 4, it's going to be 480. And let's see also the higher one. This not okay. Let's choose the 5. If you see right here, there is no 4.5. If there is 4.5, I would choose it, but I'm going to choose this one, the 5. Okay, and let's choose this one. Okay, let's repeat everything we done for all the relay downstream. For the upstream, this one, this relay, let's see, the current flowing through this relay is about this current plus this current is about 600. So let's go to this one, OCR, and choose our manufacturer, ABB and CO4 model. Let's use the second one. It's about 600, so let's go to 5. If I choose this one, it's going to not be acceptable, so I'm going to choose this one. Or this relay, let's see, the amount of current is going to flow through this relay is 203. 203, it's about 205, so let's go to this relay and choose our company, ABB and CO4, and enter. Again, let's go for the first one. Let's see, the highest value is 2 and 2.5. Let's see, the 2.5 is about 250, and 250 is acceptable for this relay, as you can see. It's 203 and the highest value is 250. This means 2.5, the pickup current, the best pickup current for this relay. And okay, now we have added all the backup setting for the relay. The second thing you will need to do is to save the project. Okay, second thing we will need to add is the instantaneous setting. Instantaneous setting for the overcurrent relay is done for the instantaneous current. So the highest instantaneous current is the current in the below the relay directly. So the value of the short circuit current right here is 6.16. Let's show the unit again. This point will show us the three-phase fault. So we are going to pick it and put the fault directly right here. As you can see, the amount of current is going to be about 6.16, and this is very high. So 6.16, let's put this below so we can see it perfectly again. as you can see 6.16 kilo ampere. So let's go to OCR and let's choose as 6100, some current below it directly. Let's, as you can see, from 10 to 40. So let's see the 40, how it's going to be the 40. When we reach the 40, we cannot reach higher, so let's see the higher value. Let's see this time as 651. As you can see, 51 give us 6.12 kilo ampere. It's the perfectly lower than 6.16, so we are going to choose this one, instantaneous pickup setting. So it's going to be 51 ampere in secondary. Let's say the delay range is going for the tripping is going to be 0, so there is no any delay, it's perfectly 0 time. Okay, what we have done for this relay, let's do it for this relay again. Let's see the OCR, and we have chosen this one, not this one, let's say this one, and we put it as 51, and we also choose the delay range as 0. Also, let's do it for the relay 3, the OCR, and also we have chosen the 10 to 40 and not 10 to 40, but we have chosen 10 to 100, and we have chosen 51, and the delay range is going to be 0. Now we have added the relay 2. As you can see. Now, if I put any fault at any point of these, only relay the operator relay 2 or relay 1 or relay 3. Let's say if I put the fault directly right here, let's see which relay is going to operate. As you can see, the first relay which is going to operate is relay number 2. The first relay is going to operate, which is going to operate. Okay, that's good. Let's see also the fault. When we see any fault at this point, relay 1 is the best one which is going to operate, the relay 1. Okay, let's also see it right here, relay number 3. Okay, you can see it right here as relay number 3 is the first one is going to operate. Okay, let's enter the data now for the relay number 4 and relay number 5. Okay, let's start with relay number 4. We are going to put the instantaneous setting for it right here. As you can see, the value of the current is 6.32 kilo ampere, 6.32 kilo ampere. So we are going to for relay and OCR, and let's choose the 10 to 20, and let's go to up to near just below 6,320. Let's go up until this value is 6,320, something below it, just below it, 6,360. Let's go below it, 6,240. This one, we are going to choose this one, and let's put it as 0. Okay, now we have entered the data for the relay 4. This means if any fault occur at this point, the relay for the one which is going to operate. So if the fault occurs this point, is going to operate instantaneously. As you can see, the relay 4 is going to operate instantaneously, about 25 milliseconds instantaneously. Okay, let's see the relay 5. Setting for the relay 5. Of course, the relay 5 will not have any instantaneous setting because this point is typically this point. There is no impedance between this point and this point and this point. So if I choose an instantaneous setting for relay number 5 and said, let's say this one, the fault right here, as you can see, it's typically 6.32 kiloampere is similar to the value of the fault in this point. This means if any fault occur at this point and both of them has instantaneous setting, then relay 4 and relay 5 will trip at the same time. And if relay 5 trip, this loop will get out of service. So to keep the continuity of service, we will need only relay 4 to trip. So we are going to leave the relay 5 without any instantaneous setting. So let's go to OCR for this relay and remove the instantaneous setting. So there is no any instantaneous setting for relay 5. Let's see the relay number 6. Relay number 6, we will have an instantaneous setting. Double click, and the amount of current is about, let's see how much. Let's put it down, and this is down. Is about 7.03 kiloampere. Let's go to OCR and let's choose this one. Okay, and let's say 70. It's about 7,000. Okay, let's go up for the first one is 7.1 kiloampere, and 7.1 kiloampere is higher than 7.03, so let's go to 7,000 or 70 backup instantaneous setting. Okay, now we have entered the data for relay 6. Okay, the last thing we will need to do is to go to each relay and make sure the integrated curve and link it to see the curve. If you can't see, let's see this curve for now. If I want to see the curve for this relay, just select it and go to this icon, the create star view. As you can see, this is the curve by 2 curves, so let's make sure the curve is smoothly connected. So we are going to choose this one and this one to make sure the curve is smoothly connected like this. Also, you can see the backup current, the overcurrent or the overloading backup current, this point. To connect it, by double click and go to general and extend and expand and also show range. As you can see now the curve of relay number 4, as you can see the value of the tripping, the backup overloading current, and right here the other value for the instantaneous setting. Also you can choose the data from right here, right click and choose setting. You can see it right here by zooming in. You can see we are using a OC or OCR, the overcurrent relay from manufacturer ABB, and the model CO4. CT we are using is 600 over 5. It's long inverse. The backup value is 5 and the time dial is 0.5, and also you can see the instantaneous current is 52 and the time delay. Okay, let's see the relay number 2. Also let's make sure the integrated and link it to TOC and OK. Also for relay number 3, OCR, this one and this one. OCR, integrated, and TOC plus IOC. As you can see, first of all, if any fault occurs at this point, the relay 2 should operate first. If relay 2 doesn't operate, relay 4 will operate. So if I have fault, let's say at this point, the sequence of operation will be, as you can see right here, first of all, the relay number 2 will operate instantaneously at 0 time, no time. Then the relay number 4 will operate if relay number 2 won't operate and disconnect this load, this fault. So we are going to make sure this relay will disconnect this load by disconnecting the circuit breaker. Then the relay number 4 will operate as backup protection. But if relay 4 doesn't operate for any fault or error, so relay number 5 will operate to disconnect all the system and isolate the fault. Also, if relay 5 doesn't operate, this means relay number 6 will operate. Let's see another operation for any. At this point, this means we won't have any current flowing through any of this load. So relay 2 and relay 3 and relay 1 won't operate. But the best case, the relay 4 will operate. So I will see right here the relay 4 will operate, then relay 5, then relay 6. Again, to see the selectivity, let's say the fault will occur right here at this point. This means the best case scenario, the relay 5, the one will operate, not relay 4 or 2 or 1 or 3. So 5 then 6. So let's see. As you can see, the relay 5 will operate, then relay 6. Okay. Of course, if there is fault at this point, the relay 6, the only one will operate, no other relays. Let's say the fault occur right here at this point. As you can see, the sequence of operation, there is OC50 and OC51. The OC50 represents the instantaneous tripping, and 51 represents the inverse tripping or overload tripping or overcurrent tripping. So the 50 represents the instantaneous. So when the fault occurs at this point, the relay 2 will operate instantaneously with 0 time. But after a time, let's say right here 1 second, nearly 1 second, or 1000 millisecond, nearly 1 second, the second relay number 4 will operate. Okay, now we want to see all the relays at the same time in star curve. So let's select all the by control and select the relay number 4 and relay number 2. We want to see all of them in one star view. So I selected all of them and choose from right here star view. As you can see, all the relays is as star view. Let's double click on it and go to general and choose the range, external, and okay. Let's zoom in to see. Okay. As you can see right here, the first relay, this one is this relay, okay, and this one is this relay, and this one is this relay. Okay. As you can see, there is a conflict between these three relays. So we are going to want to change the relay up. To change the curve up, we can do it by this time dial. This time dial is going to give it up. So let's say instead of 0.5 for the relay number 6, let's say 1. If you see, if I increase it to 1, it goes up. Let's say 1.5, and press OK, and this relay, let's say 1, and press OK. Now as you can see, all conflict of relays, there is no conflict of relays. Some other things you can do by right click and plot option and go to grid. You can choose the grids. Let's see, instead of, let's choose 2 only to see the logarithmic grid. You can add the project name and location as you want as legend and save it as you want from right here. Okay, this is the total star curve for all relays. Double click on this relay just now. As you can see that it will not operate instantaneously, but by delay time you can change it to operate instantaneously like this, to operate instantaneously only, to make sure this relay will operate instantaneously. Also, for this relay you can change it as you want for the best things for you. Now we have added all the relays and see the sequence of operation. Let's again see the more complicated sequence of operation. Let's say the fault occur at this point. This means the only relay should operate first is relay number 3, then relay number 4, then 5, then 6. Relay number 2 and relay number 1 shouldn't operate. So let's see the sequence of operation. First of all, in sequence of operation, as we said, the relay number 3 will operate as instantaneous setting, then relay number 4, then relay number 5, then relay number 6 as a sequence of time like this. There is more things you can do also. Let's see. Let's select all of them. Let's remove this fault and select all of these relays, and let's go right here and also double click on here and show range and extend, and also the grid, display the grid, and instead of all of these let's choose 2 only and press OK. One more things you can do, I forget to say, you can see right here, let's zoom in first. To see the difference of time in operation, as you can see, the y-axis is the time, the x-axis is the current. Choose from right here the timer or the time difference and choose the first curve, this curve, and the second curve, this curve. You can see right here the value of time as 1.54 second. This means the merging time between these two is about 1.54 second. Also, again, if you didn't understand the first time, let's say this curve and this curve. Now you can see also the time is 1.27 second, the merging time. Also you can see for the last one, let's say this one, and let's say this one. Okay, you also can see the merging time also. This means if we have any fault at this point, the first one is going to operate is relay number 2, then relay number 4, then relay, then this relay. Okay guys, that's for today. Thank you for watching. See you in the next course. Goodbye.